All right, so it seems that most of you are here already. Okay, so let me just give you guys another example. Mm, Let's just use Notepad. All right, so for example, we have yellow, blue, and then brown. And the last one for the tolerance is, let's say, gray. So as you guys can see, the first one is yellow, so just get the value of that one, so which is 4. And then the second one is blue, which is 6. Okay, and then your multiplier here, which is the third one, is brown, which is 10. We can put here times 10. And then the last one, so you can neglect this one for now, just solve for the first 3 bands. So 46 times 10 will give you 460, 460 ohms, right? And then for the tolerance, okay, so you can just put here positive minus 0.05%. Okay, so supposedly we have here positive minus. Okay, as you guys can see, where is that one? Let me just show this one to you guys right here. So in every bands, okay, or in every fourth band rather, for the 4-band resistor, we have here positive minus 1% for the brown. We have here plus and minus 2%. So yeah, as you guys can see, we have here plus and minus. Just an indicator that it's ranging from this positive, and then if you're going to deduct the negative on the resistor, all right? So it could be less or more for your resistor. And then if you're going to compute the value for this one, so just get the 0.05 of 460. So 460 times 0.05, so 23. So 460 minus 23, so could be ranging from 437 to 400, is that 23? 23, 460, 483. So the value of your 460 ohm resistor could be ranging inside of this one, 437 to 483. Okay, so that's the tolerance that is given with this kind of resistor. So you guys are able to understand it now?
Yes, sir.
Sir, question po.
Yes.
Sir, hindi po ba siya 0.23 kasi 0.05%? So, parang 0.0005 po siya pag i-multiply.
460 times 0.0, ano, percent nga pala to, so 0.005. Check na natin. I'm not really sure anymore. Okay. So I think you just multiply this one right away, unless it will become 0.0005. So we have here yellow, blue, brown, right? Yellow, blue, brown, and then gray. 0.05. Yeah. Okay. So the minimum value or the range of that one could be 459.77 to 460.23. So it's super close already, but not exactly 460. So that's the tolerance given. So this 0.05, so my bad, this 0.05 will become 0.0005%. I mean 5 if you're going to remove the percent already. Okay. So thank you for that one, Miss Michael. Am I right?
Yes, sir. Opo.
Weird naman, Michael. Parang pangalan ng lalaki. Anyway. So any other concern? So this one is 459.77. 59. And then this one is 460.23. Right? So are we okay now with this 4 strict resistor? Or do you guys need more example? No? So why don't you guys give me a thumbs up if it's already okay? And then what are the other reactions? Do we have and let's see the reaction here. Anyway, so give me a thumbs up, guys, if you guys are already good with this one on how to measure a resistor using a color coding. Okay, maybe 4 out of 18. How about the others? Please speak now if you're still confused on how did we get this one, so that we can have one more example. All right, so it seems that, I don't know, maybe we are not around or they're sleeping already. Anyway, so yeah, that's it for the laboratory number 1. Okay, so before we proceed to the LT Spice application, so let me just show this one to you guys. So under watch videos, so this is where you can watch all of the tutorials that I have included on the module 1 overview. And then later on, this is where I will put the links for the recorded Zoom meeting. Okay. And we have here two. Oh, yeah, I prepared two, not actually two, one only, actually. So the other one is actually just a link wherein it will lead you to this website, which is the All About Circuits or Resistor Color Coding Calculator. Okay, so this is where you can practice or verify your answer whether you really get the correct answer or no. Okay, and the other one is just a short activity. So this is a practice quiz, okay, which is a multiple choice. So just 10 questions. Okay, so I would like you guys to answer this one. Okay, so this will serve as your practice before answering the laboratory number 1, right? And for the assessment, so this is just where you're going to submit the laboratory number 1. So I would like you guys to submit it in a form of Microsoft Word or via Notepad or uh, any other forms of text. Okay, so do not do this one handwritten, but do this one via electrical or what do you call this one? Yeah, electrically, forget the term, but via software, okay, or via computer, not handwritten. All right. So are we clear with this? Yeah, with this one, guys.
Yes, sir.
Yes, sir.
Yes, true.
So for the last one, which is your case study, Okay, so I would like you guys to read these facts, and then we have here the question. Okay, so this one is case by case. So if you agree, so I would like you guys to state your thoughts regarding with that one, and if you disagree, I would like you also guys to state your thoughts also. Okay, so what is your opinion if you agree and disagree? Okay, so this is a discussion, a graded discussion, so 20 points. So this one is even higher points compared to your laboratory number one. But don't get me wrong, guys. So even though this one has a higher points than your score of your laboratory number one, which is just 10 points, you still need to do this one. Okay, so this is a requirement for you guys to be able to complete the scores or pass the scores. So even though you have a grade of 95, but you wasn't able to finish this laboratory number one, then you will not be able to pass this one. Okay, I'll give you a grade of IS. So you must finish all of the laboratories. That's the major requirement of this subject. All right? So are we clear with that one?
Yes, sir.
Yes, sir.
Yes, sir.
All right, so do you guys already have your LT Spice with you? Have you guys already downloaded this one?
Yes.
Yes, sir.
Okay. Is there anyone here who wasn't able to download this application yet? Maybe you're using your smartphone right now, so that's the reason why you wasn't able to download and install it. Is there anyone here who has that? Okay, so Mr. Santa Cruz. So I guess he's using his phone right now. Anyway, once our class is done, so for those who wasn't able to download this one, so please download this one as soon as possible, and then practice and explore. Okay. All right. So to those who already have their LT Spice with them, please open it. Okay. So it will lead you to this interface. So are you guys in this interface now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so the first thing that you need to do is, of course, create a new schematic. Okay, since this one is still not a blank canvas, you're still in the introductory page, which is a blank. As you guys can see, it seems like a turtle. Anyway, so to create a new schematic, so you can do it right here, file, and then new schematic, or you can just simply click this one, new schematic. Okay, or you can just, I think, do it via Control N. Okay, which I just did. So it will lead you to this interface. So my interface might be different with your interface. Yes, Mr. Santa Cruz, do you have a question?
Wala, sir. Napindot lang po. Sorry.
All right. So for you to have your own color preference, so you can check, where is that one again? Here, color preferences. Okay. So in here, you can change the color of your schematic. You can even change the waveform. Okay. So wait a second, please. All right. So sorry for that one. Okay. So in here, you can change the color of your schematic. Okay. So in my case, I have this kind of color, but you can, experiment. Sorry. So you have to change this one also. Okay. So initially this one is wires. So if you want to change the schematic color, so choose background. Okay. So as you guys can see, you can experiment any color that you want. Okay. But in my case, I just chose the white one. Okay. Something like this. So that depends to you. And another thing that we are changing, so some of them are changing the color of the wires. So basically this one is black, okay, but you can change this one into green, into red, into yellow, or any color that you want. Okay, so it's okay. And you can even change other components here, the junctions, the component body, the graphic plug, and so on and so forth. So there's a lot more, but mostly the one that the user is changing is the background color and then the color of the wire. Okay, the others are just uh, not really that uh, a big issue. Like for example, junctions. That's a small thing that we are seeing here. So it's okay if it's blue or red. So that depends on you. But in my case, I'll just use the default one for the junctions. So the only thing that I have changed is the background, which is I made it a little bit more white. Okay, so in your case, it is now up to you. Okay, so that's it for changing the theme of your background and for the wire. And the next one that you need to know is this panel. Okay, let me just make it a little bit smaller since these icons are popping up. All right, so the next thing that you need to know are the icons right here. So let's start from the left side. So we have here the new schematic, which we already did. Okay, and then we have the open folder, or you can open an existing schematic. And then here's where you can save, or you just simply use the, or do the Control S, okay, instead of clicking it right here. And then we have here the control panel, and then we have here for you to run the schematic diagram if you want to simulate it now. Then we have here the help. Let's say it's already running, you want to stop it. And then we have here the zoom. Okay, if you want to zoom a certain component, if you want to pan. So in doing the pan, so you can just do the left click thing. Okay, like just click the background, and then you can pan it already. So you can navigate anywhere. And then we have here the zoom back, wherein you want to go further. You want to zoom certain component, etc., etc. And then if you want to zoom fit, just click the space. So this space is the most powerful zoom, or call this one zoom back application. So this will fit you guys the components that you have on your schematic or background. So like for example, I have here a component ground, and we are currently focusing here right now. I have resistors, and then I have connected everything on this side. And then let's just say that you want to check all of the components that is inside of your schematic. So just click space. Okay. So oops, why did I have a ground component here? So in that way, you'll be able to know that you have, maybe you've accidentally clicked the ground and then place it here. So that way you'll be able to avoid getting some errors, because you just have some uh, unwanted components on the on your schematic. All right. So were you guys able to follow so far, at least up to this point?
Yes, sir.
Yes, sir.
Yes, sir.
All right then. Okay, and then the next one here is tile windows. So in here, I cannot show this one to you guys right now. So this one is the simulation part, wherein we cannot simulate anything yet for now. So later on, we'll move on to that one. And then right here, we have tile windows. Let's say you want to have this schematic. Okay, let's say you want to compare this half wave rectifier to the full wave rectifier. Okay, or let's say you're just basing your circuit from this left side or bottom side to the upper side. Okay, so if you have this tile windows, it will give you guys two windows, of course. So where is the two windows? sorry. So you have to create another schematic, of course. Okay. So in that way, if you have another draft, okay, as you guys can see, we have draft 18 right here, but maybe in your case, you have draft 1. So you need to have another draft for you to have two windows. Okay. So it could be in a form of like this. The other one is right here, and then the other one is right here. Or you can do the other interface, like, or other layout rather, not interface. Like it's one side by side. So the other drop is right here, and then another drop is right here. Okay. If you want to have 3 windows, you can have this one. And if you want to close all of those windows, then you can just click this one. Next one here is cut. So let me just click this one and then remove this one. All right. So this cut right here, or scissor, of course, will cut or will remove a certain component. So let's say you want to remove this resistor. So just left click this one. And that's it. So you want to remove this certain line, then just left click this one. Left click, left click, left click, left click. Until everything's scanned. Right? And then the next one here is copy pasting. Yeah, copy pasting a component. So let's say you have here a resistor and then you want to copy this resistor. So let's say this one is 10K. And you want to copy this 10K. Let's say you want to have 5 more resistor which has a value of 10K. So just click this one, copy, and then place it right here. And then it will not give, it will now give you an R2 and another value, let's say R3, another one R4, and so on and so forth. So you can do that one as many as you want. So just copy a certain component and then paste it anywhere that you want. All right. And then we have here search. Let's say you have put a label on something. So you've changed the So for you to search that one, so just click this search button right here, and then put the label or the name of that certain component, and then it will be highlighted to this color, which is yellow, which is not that visible anymore. So anyway, since our components will not exceed to maybe 20, you only have a component of 1 to 5 or maybe less than 10. So looking for, that certain component is not that hard, especially if you click the space button. Okay, it will show you all of the components that you have on your schematic. All right. Then we have here for the print setup. Let's say you want to print this schematic. It's possible. So you can do that one right here. And then the most important component that you're going to use, of course, the wire. So this pencil represents the wire. Okay. So the shortcut key of this one is F3. Okay. So instead of clicking it right here, you can just use F3. Okay. Then you can now use the wire. Okay. And then the next one here is the ground. Okay, so you guys can see ground starts from the letter G. So you can just click G. Okay. So maybe you guys are wondering why the W is not the wire. So I'm not also sure with how this spice work, but for the wire it's not W, but it's F3. Okay. So that's one thing that you guys need to be aware. Okay, so you guys might get angry. Why are my wires not working? Okay, so just click F3, not the W. All right, and then we have here the label net. Okay, so aside from the label or the name of our individual components, you can put another labels. Okay, like for example, you have here, let's say node A. Okay, so let's say node A. Just put here node A. Okay, so in that way, you are now able to label this wire, okay, or this connection letter A. So this is very helpful. Let's say you're measuring the letter A node to letter B node. Okay, let's say this one is a parallel circuit. Okay, you have 3 nodes. And the only question is to measure the value of your letter A and B. Okay, so let's say, what is the summation value of your R2 and R3? Okay, so in that case, you know that this one is the node A and then this one is the node B. So just simply label or namings. And this will also show on our graph later on the simulation graph. Okay, that this one is the node A and this one is the node B. So from node A, the current right here, let's say 5 milliamps, but at node B, the current is already 3 milliamps. So this is also very helpful to identify the parts of your circuit. So, yeah. Right, and we have here resistor. Okay, so this, you guys write out this one. So just click letter R, and then it will give you a resistor. And escape to cancel. Okay. And for the last two, okay, we have here the capacitor and inductor. Okay, so we might not be able to use this capacitor and inductor in this subject, but in the future, like in your fundamentals of signals and sensors or electronics subject, so that's the time that you're going to use this capacitor and inductor. Okay. So for now, so this is where you can find the capacitor. Okay, so just click letter C and then letter L for inductor. Okay, and then the next one right here is the diode, which is not also part of our subject. So this one is for electronics. And then right here is the component. This is where you can find all of the other components, which I doubt that you guys will be using this one for now. So the only thing that you'll be using on this component, on this component is the voltage. Okay, so this is where you can find the voltage source. All right, so just click that one, or you can just simply search it right here, voltage, then it will give you this one, voltage. So just click OK, and then you now have your voltage. Okay, so the others, the op amps, the BAC, ABC, comparators, so those components will be on the higher subjects. Okay, since you guys are still on the basic parts, so the only thing that you're going to use with the subject is voltage, resistors, and ground, and then wires. Okay, so are we clear with that one, guys?
Yes, sir.
Okay, and then the last two is the move and then drag. Okay, so move here is of course to move a certain object, and then drag here is to move multiple object or components. So let's say you want to move everything, then you can do the drag option. And then let's say you want to rotate a certain component. So this is the undo. Okay. You guys already know this one. This one is F9. And we have here the red, which is shift F9. And then for the rotate, we have here, let's say, this resistor, and then you want to have a horizontal implementation of this resistor. So you can just move this one first. So move and then control R. Okay. Well, you can still do it by clicking this one, but as you guys can see, what happened here is I'm moving also my interface moving upward. So which is very unlikely. So instead of doing that one by clicking it right here, so just move this one first and then control R. Okay, so that's a shortcut for you guys to rotate a certain object or component. Okay, so let's say you want to put it right here, and then another resistor here. So yeah, it's possible. And then the other one is mirror, okay, wherein you're just basically going to mirror that object, okay. So this one is very helpful if you have an op amps, it's a universal op amp. So as you guys can see, we have here negative and positive. But what if you want to have positive on the top and then negative on the bottom, okay? So you might guys be thinking about rotating this one, but it's not possible. Okay. So yeah, it's possible, but it's now facing the other way around. So for us to make this one possible, you should click the mirror option. Okay. So in that case, I now have the positive on the top and then negative on the bottom. Okay. Well, this one is only applicable for this kind of components, but for the others, you'll not be needing this one. All right. So yeah, that's it for the components. And then for the shortcuts, I would like you guys to explore the LT-SPICE commands. So mostly it's starting from F1 to F9. So just keep on, randomly clicking those, and then it will lead you to a certain command. So for F4, let's say label. For the F2, it's the components. For the F3, it's for the war. F5 is the cat. F6 is copy. F7 is the move. And then F8 is a grab. And F9 is the undo. And then the others are R, G, C, L, etc., etc. All right. So let's say you want to measure the current of this one. So let's say we have 5 volts. We have 5K, 10K, 10K, 5K, 10K. All right. So it's very simple. So in every circuit, you must have a ground. Okay, so this is very important because if you will not put a ground here, it will give you an error. Okay. It will ask for a ground. All right, so to run this one, just click this running man. Okay. And then let's say you will simulate or run this one for 50 milliseconds. So 50 ms. So for now, we will use only transient. Okay, the other one is AC if we have an input of AC, and this is flip if we have still an AC input wherein it will be measured by DC. Then we have noise, DC transfer, and then DC output. So in some cases, we're also going to use this one, but you can actually have everything on the transient part. Okay, so this is just another way of measuring DC inputs and outputs. But mostly transient will be good, will be fine. All right, so yeah, that's the only thing that you need to put on this transient simulation command. So 50 milliseconds. Okay, so it will give you this graph, and then let's say you want to measure the voltage right here. So it will give you 5 volts. Okay, but what if it's already on this side? Okay, so as you guys can see, we now have 1 volt since it already passed through our 10K resistor. Okay, so how did we get this voltage? So just use the Ohm's law. Okay, and so on and so forth. Okay, so let's say you want to measure the current of this one, the current of your R2. So just put it on your R2. Okay, and then it will give you this icon. Then it will now give you the measurement for the current. So as you guys can see right here, we have a reading of negative 0.4 milliamps. And then for the R1, we have here 0.2 milliamps. Okay. So yeah, that's it, how to measure a voltage and then a current on a certain component. Okay, so we don't have enough time anymore, so we will just continue the rest on part 3. Okay. So I thought